Here is a quick guide to get you started using the Elvis board. That's the platform that we use for non-electrical majors to be able to do circuit slabs, and it's a little simpler to use than a breadboard by itself and all the different discrete testing components. So first of all, this is what the Elvis board looks like. It's got a number of different input and output options. It has different types of supplies that you can get. It should appear on your particular bench have a connection to the computer. This one's not connected, but most times there will be a connection right here that leads to the computer. And there is a lot of stuff on here that you won't use. In the middle is where you would build circuits. This is a breadboard and it's used for circuit building in general. So first of all, the different inputs and outputs we use in 2305. First of all, at the bottom, we have several types of power supplies that you can access. The very bottom gives you standard plus minus 15 ground and 5 volts, so that's what you would get if you connected. And where you access them is in the pins next to them. Now I know this doesn't look like it's next to it, but that just has to do with the angle. You can actually check which row you're supposed to access by looking at the numbers. You'll notice that supply minus up here says 50, and then below it are these, so we know that 51 here is actually plus 15 and this one is minus 15. And when you are connecting, please look straight down when you're trying to line these up, because if you're at an angle you can miss it and you might be connecting to a power supply you don't want to. The access points here, there are 4, and horizontally they're all connected together, so it doesn't matter which one you use. Any one you use on this row on 51 will give you 15 volts if the board is on, and so forth. So all these points are connected. It gives you several options to connect wires and bring those voltages to your circuit. The next area is the variable supplies. This will give you a plus and a minus supply that can be adjusted up to 12 volts or minus 12 volts. And these again have pins. You'll notice that supply, again, supply minus says 50, so we know this one is going to be for that particular supply. And then we have a ground in the middle and a positive variable supply. And the values of those supplies will actually be controlled from the computer. So you will have a variable power supply window on your computer, and you'll be able to set it up to be whatever value that you want. At the top, right up here, you see something that says FGen and function generator. This is where we get our AC signal. And when we get to that point where we need an AC signal, you will again control that from the computer, and you'll access it actually from these pins up here. You'll notice that AM is 35, so 2 above that would be this row right here, and that's how you would access the AC wave that you set on the computer. Up here, if you were measuring AC signals, which we'll do later, you would use these 2 channels and you would connect a BNC to dual alligator clip or oscilloscope probe to that BNC connector, and then the other end would go to your circuit on the board and you would make measurements. We will talk more about how to do that later. That's just what those are for. You'll notice at the top there's also a way to connect the function generator up here. We usually don't use this connection mainly because we tend to run out of BNC cables, so we usually use the other connector just to eliminate that problem. At the bottom are the meters that we use. This would be the digital multimeter volt ohm connection with a common, and you would connect banana leads into those holes. You use black for common and red for volts or ohms. It makes it much easier to keep track of what you're doing if you color code that. And the same at the bottom with the ammeter. The ammeter connects again the black to common, but we use this output here for the ammeter, and we use that to make our connections. How do we connect up circuits on the breadboard? This can often be a source of confusion because breadboards are not obvious in how they work. So first of all, you'll notice that there's a vertical, well, two vertical lines connected sort of in a set here, and those points are connected all the way from top to bottom. They actually go one into the other. And the same on the other side. We have the blue connecting lines all the way down and the red going all the way down. And that means basically if you wanted to have multiple connections for, say, plus 5 volts and ground, you would connect your ground connection here to this blue, and then that would give you a ground all the way up, and the same with your voltages if you needed more than one point and more than one circuit, which you will have later. You might want to connect to this bus, and then you'll have that value all the way up and down. The horizontal points are connected together in groups of 5 in the middle of the board, which gives you a way to connect your components, and they're connected that way all the way down the board. So every horizontal group of 5 is connected. The channel in the middle separates, so the groups of 5 on the other side are connected together, but not to the groups on the other side of the channel. And to the left, where we have input connections, we have the same thing. We have groups of 4, and those horizontal connections are all connected together. When we're connecting a circuit, you'll notice that in this case we have plus 15 connected right here, and we go up to this group of 5 where we have a wire coming in and a resistor going out. In the middle here we have the 2 resistors connected to the same node here, and then at the bottom we have the ground wire coming from ground and going to this point. So that would give us a series circuit. A parallel circuit will be connected much the same way. We have the same voltage. I know it doesn't look like it, but it is. And then this time we have 2 resistors connected at the top node, 2 resistors connected at the bottom node, which makes them in parallel. These are acceptable ways to connect resistors in general. You either have to go to 2 different horizontal groups and separate them by some kind of space, or you can do horizontal groups that are separated by a trough. Either one of those will work as long as you're connecting one end to one group of 5 and the other end to another group of 5. Do not do this. It's a very common mistake, but if you connect the resistor to the same group of 5, you're basically just going to short the resistor and it won't be in the circuit. So don't ever connect a resistor to where you have both ends in the same group of 5. How we power the Elvis is, first of all, at the very back, right up here, you can't see it in this picture, but there is a main power switch. And when you turn that on, the main power LED will come on. If there is a USB connection, which there isn't in this case, this other light will also come on that says ready. In this case, only one light came on because I don't have it connected to a computer. Once you do that, you'll set up your circuit. In this case, I'm not setting up a circuit, but you could. And then you connect actually the power to the supplies. And you notice when you turn this on, you'll get a green light here that says that the prototyping boards are powered. And then down here, plus 15, minus 15, and 5 will all light to show you that they're active. And that way you know that they will be active. The control board or the computer will control the variable supplies, but it still needs to be on when you are controlling it. What happens if the board doesn't work right? It happens sometimes. Usually the board does work. Usually it's more of a student problem. So I'm just going to illustrate one issue of something that might happen and what you should do to correct it. So let's say you turn your board on, and you turn it on and you notice that only 2 of the 3 lights come on. If that happens, you've got a problem. It means that there's a short in your circuit somewhere, so turn it off and fix the circuit, and you'll see the circuit jump a little bit because I fixed it. Then turn it back on, and the LED should come back on if you fix the problem. If it hasn't, then you still have an issue. The only other possibility is there are occasionally boards that we own that just have LEDs that don't work. So if that's the case, if you've done troubleshooting, or if you've disconnected everything and that LED still doesn't come on, you may just need to check it with a meter and make sure you're getting the proper output. And in that case, just remember the fact that that particular LED doesn't work. So that's going to get you started. You'll learn more about the board as you go along, but that's enough for you to do the first couple of labs.